multiplication method for hash functions. Still, the first video we talk about, something you are interested in, hints for selected questions in final. In a previous video, I already explained several questions related to the final. After that, I look at other questions. Some of the questions relatively easier, so I leave it to you, so you can answer those questions easily. But some of the questions probably you need a little harder, so I want to explain here so you can get a better ideas to solve those problems. So let's start these questions. All right, so these two questions from homework assignment. Homework, we have two similar questions, but for different numbers. 7, right? But here, because those questions, many students couldn't do well, so I want to check you another time. And this time, hope you can solve it, much better than last time. So I just changed from 7 to 9. All right. So, but here, I use that 7 version because this 9 version leave to you. So I do not want to solve it. Okay. So you need to solve it by yourselves. All right. So let me use the 7 version. First, when we merge, when I grade those two questions in your homework number 2, I noticed some problem. The merge sort. First, the merge sort. Many students are not familiar. How do we apply merge sorts? Merge sort. We apply the merge step multiple times, but those students only apply one time. That's not right. Remember, we do divide and conquer. After we divide the array into many small, very small subarrays, then we need to merge them. Not merge once, we need to merge many times. So many students didn't understand that part. All right, so let me show you here. All right, so homework question, 7 element. Okay, 7 elements. So let's do the divide and conquer. So here, let me put 7 elements here. So when we do division, we try to split the array as even as possible. Okay, so one split there, another split here, and another split here. Okay, all right. How small each array? 2 or 1 elements. So the bottom level, the lowest level, 2 element or 1 element. So we can stop. Okay, so 2 elements. So we know because we need to do one comparison to get it sorted. One comparison to get it sorted. One comparison to get it sorted. Right? The preparation. We can treat this step as preparation. After that, then we merge 2 adjacent subarrays. But when we merge, we consider worst case and the best case. Right? So the worst case, so when we merge 2 arrays with size m and n, so let's review the formula. Worst case, the formula is m plus n minus 1. The best case, the formula is minimum of m and n. Okay, so now we do the merge. The first time when we merge these 2 subarrays using worst case, best case, twice. Okay, The worst case, the number of comparisons, total number of elements minus 1. Total 4 elements minus 1, 3. Okay, all right. So here I like to write this way. 3 vertical bar 4. Yeah. 3 comparison, the result array 4 elements. In this way, I can use these numbers next time. Okay, all right. Combine these two arrays. Yeah. Total number of elements minus 1. Total 3 minus 1, 2. Yeah. 2 vertical bar 3. Okay, all right. Now, the last round merge operation. Yeah, all right. Worst case, total number of elements minus 1. 7 element minus 1, so 6. 6 vertical bar 7. Okay, so we get all the elements sorted. So we stop. Now we need to calculate total number of comparisons. Okay, all right. 3 preparation step, we need a 3, right? All right. Next round, 3 here, 2 there, so 5, right? So next round 5. The last round 6, so plus 6, okay? Then total 14. This is the answer. This is the answer. Homework question, okay? Yeah, here I'm talking about homework question, okay? Yeah, all right, yeah, 7, not 9, okay? All right. The second one, so let me do this another time, right? Yeah, let me do this another time. Try to make sure you are familiar with the whole procedure, all right? So let me repeat this diagram another time, okay? 7 elements. Divide, okay? Yeah, all right. Preparation, 1, 1, 1. Get these subarray, base level subarrays sorted. Yeah. Next level, this time using new formula. Okay. Minimum of, so merge these two arrays. The best case minimum of the 2 size numbers. So that's 2, and size 4. Okay. Here, minimum of the 2 sizes. That's 1, the size 3, okay? All right. Then the last round merge, all right. Minimum of the 2 size numbers, that's 3, okay? Total size 7. Then we're done, okay? Now, final, tabulation, right? Yeah, tabulation, all right. So 3, next round 2 plus that 1, also 3. The last round 3, another 3, so we get 9. So that's the answer. Yeah. So those 2 homework questions. Yeah. You have the complete procedure. How do we solve these 2 questions? Now you apply the same procedure on 9-element array, and then you get your answers. All right, so that's the first slide. Second one, this question, number 15. Max heap whose value correspond to array indices from 1 to n. What is the smallest possible index for second smallest? Yeah, our homework question for the minimum value, right? The minimum value. So the answer is 1, right? Yeah, answer is 1. But now I ask you the second smallest value of the heap. So then many students may feel it's pretty hard. How do we know the second smallest? Right? Yeah, here I want to do, here, this will give you a hint, right? So you need to get the answer by yourselves. Here I want to explain the situation we have. All right, so smallest possible. Look at the smallest possible index. There are many different possibilities, right? The smallest, second, so we need to understand the situation for that smallest possible index. Okay, yeah, index case. Yeah. All right, so here, let's look at the highest possible height for the second slide. So what is the largest possible height? Right? Yeah. Second smallest value. Largest possible height. Okay? Think about that. Yeah. All right. So here, let me draw diagram. Yeah. General case. Yeah. Yeah. That's enough. So I do not need to draw, too high. All right. Second smallest, not the first smallest. Okay, second smallest, not first smallest. All right, yeah. So look at the picture. Second smallest. Okay, so how do we interpret second smallest? Value. Okay, interpretation is only one element is smaller than it. Okay, yeah, only one. Okay, so that means what is the largest possible height? It can only have one child, right? Yeah, because that child has smaller value than the parent. Child has smaller value than the parent. Okay, we want to lift its high number as much as we can, but we cannot lift too much higher, because if the height is too big, then there are too many nodes below it, right? But the second small, you cannot have too many below you. You can only have exactly one below you, right? So that means the highest possible case, you can only have one child right under you, no more. Okay, one under you, but no more. Okay, so that one we can treat as the minimum. Okay, yeah, and this is second. Okay, second smallest. All right, yeah, the height, largest possible height equals 1. Okay, you can only have height 1. You cannot have height 2, right? Yeah, so that number can only have height 1. Okay, now you think about what element with height 1. So think about this question. What element? Okay, element. Yeah, the element. What element means? Its index, right? Yeah, you look at its index. What element with height 1? Height 1 has the smallest index. How about that? Because smallest possible index, right? Smallest index. Okay? Can you find the answer of this question? What element, this one should have height 1, right? Height 1, okay? Now I want to refer you to the previous video. We talk about position numbers. Position numbers the same as indices, okay? Position numbers, indices, no. Same. There is a height 1 block, right? Yeah. Look at the previous video. There is a height 1. Previous video means module 6, B, part B.1, M6B1. Okay, look at that video. Height 1 block. Yeah. Height 1 block. So you know what are the indices for height 1 block. Okay, yeah. So that's the range. The range is given. Then which index in that block is the smallest? Then you get the answer, right? Yeah. So this is the whole analysis for the question. Whole analysis for that question. Okay? Yeah. Yeah. Hope you can understand this whole story. Yeah. All right. Next one. Yeah. This question I modify from one of our homework 2 question, yeah, but I do not change much. I only change by 1. Yeah. That question except 1 node, right? But here I change to 2 nodes. Yeah. 1 node, 2 node, what's the difference? Here we look at the asymptotic notation, right? Yeah. 2 nodes, you need to fix 2 nodes, right? You need to do the max heapify operations on 2 nodes. Yeah. For 1 node, you know, you need log n steps. Okay, the worst case. Yeah, worst case log n step. 2 nodes, you need to do this twice, right? Twice. So what's the answer? Okay. So that's the meaning of the question. Yeah. So that's the, you know, what I ask for. Yeah. Yeah. That's the meaning. Yeah. 2 nodes, right? Yeah. All right. The last question I want to talk about, question number 22. Yeah. So this one, I remember I explained it in quiz 4. Yeah. So quiz 4 video. Yeah. In quiz 4, I explained the details in that video. Yeah. But I'm afraid many students didn't watch that video. Yeah. You know, based on my experience, you know, approximately 1/2 of the class, 1/2, 10 something, 1/2 of the class do not watch, you know, all the videos. Yeah. Typically, yeah. So here, let me explain this question another time, yeah, because that's so important in the final. You don't want to miss it. Yeah. All right. So here, for the best case, yeah, merge minimum number confidence for the best case. So we know we use the formula, this formula. Yeah. But we have 4 sorted arrays. When we merge them, there are so many different ways. But we don't want to try all those ways. No, too much work. Okay? So we only want to try, you know, some good cases. You know, some cases that can give us the best chance to get a minimum number of comparisons. Okay? Yeah. Here we try 2 cases. For this case, we only try 2 cases. Okay? Yeah. Yeah. So when you work on this, if you try 2 cases, look at, you know, which one gives you the better solution. Then you take that one. Okay? So what 2 cases? Yeah, case 1, case 2. Yeah. So let me draw 2 halves. The first half, case 1. Okay? Case 1 here. Case 2 here. All right. Okay. So case 1, we do this grouping. Yeah. grouping in this way. Okay, the grouping. First time we merge two arrays with the smallest sizes. So usually we call the greedy algorithm. Okay, the greedy algorithm idea. Yeah, these two. Okay, we merge these two with the smallest possible sizes. Yeah. When we merge, apply the formula, the number of comparison best case, 10, the size 25. Yeah, let me still use that notation. Vertical bar 25. Okay, the first time we merge, we get 25. Yeah. Then next we have these three arrays we need to merge. We still pick the two smallest array sizes to do the merge. These two. Okay. Then when we merge, the number of comparisons minimum of these two sizes, that's 22, and the total array size 47. Okay. All right. So the last merge, because only two arrays left, so we just do it. The best case, minimum 37, total size 84, right? Yeah. Oh, sorry. Yeah. All right. I should not solve this problem for you. Yeah. Anyway, yeah. Here I show you. Okay. Yeah. So you get answer. All right. Yeah. The second time, case 2, yeah, because the greedy algorithm, so for this class, I do not have chance to cover the greedy algorithm topic. The greedy algorithm has a property, it may not give you the best solution. Okay? It cannot guarantee it provides you the best solution. So for that reason, we need to consider another case. We can get a better solution. So that's we do this grouping. Okay? 10, 22 first. Okay? Yeah. 15, 37 next. Okay? So when we merge minimum 10, 32, okay? Yeah. Minimum 15, 40, 52. Right? Yeah. Then the next round, we look at the size part, the minimum 32 and total size 84 still. Yeah. Okay. Then you count the number of comparisons, then you do the comparisons. Yeah. When you do these two cases, yeah, that should be good enough. That should be good enough. Yeah, because we try to take advantage of arrays with the smallest possible sizes. So that's why we look at these two cases. Yeah. All right, for the worst case, yeah, because next question, you need to do the same, similar problem, but for the worst case. Okay, for the worst case, then only case one has the best chance to give you the best solution. Case 1. Yeah. Case 1. Yeah. For the worst case, the story is different. For the worst case, we can pretty much prove case 1 will give you the best solution. Okay, we can prove it. Yeah. So the proof is not very hard. Yeah. So you only need to try case 1. That's enough. Although you can try other case, but extra work. Yeah. Yeah, because we can prove mathematically, yeah, case 1, the greedy algorithm can give you the best solution. But for the worst case, okay, yeah, not for best case. For best case, we cannot prove it. For the best case, we cannot prove it. But for worst case, we can prove it. Okay, yeah. All right, yeah. So that's all the hints I want to talk about for the final. Yeah. So the remaining just leave to you. Yeah. So you complete it. Yeah. All right. So let me stop here. Yeah.